So hey guys, it'll be very hard to follow up that performance, but I'll try. Hope you had a great lunch. So I'm Siddharth, and I am an iOS engineer at Flipkart. I've been working there for the last 2 years, and it's been a very exciting journey this far. So just a little agenda for today. So we're going to talk about why I am here to talk about a networking library, and we're going to talk about what is currently out there and what is it that we have built that might solve your problems in a little more elegant way, right? And we'll also talk about performance benchmarks and how it compares to the existing tools out there. So there is a lot to cover, so I'll just jump right into it, right? So the question is, this is something that I asked myself also, why am I doing a networking library in 2017? Like, it's 2017, people are working on AI and ML. Why do we want to do networking libraries at this point of time, right? And what we realized at Flipkart was that our networking requirements have changed a lot over the years, in the sense that it's not just making HTTP requests anymore. It's about keeping track of your sessions, keeping track of important information that you want to communicate with the server, and there is a lot to expect from a networking stack these days, right? So, basically that's what this statement says, that modern apps have really complex networking requirements. And what I really mean by that is that we expect some capabilities out of our networking stacks, right? And we normally end up building them on our own. For example, we might want to attach OAuth tokens to every request, or we might want to have some kind of system permissions before we fire a network requests. In a similar way, we might have session systems that we that in a networking stack that we might want to attach some headers, or we want to take information out of every request that completes, so that we can maintain keep the information on the server and an app in sync, right? And also we want our apps to be adaptive to network connectivity. So on slow networks or on patchy networks, we want our networking stack to take care of what is going on, right? And in a similar way, where do I keep my networking code in my app? Because all the way from when you start an app, all the way to legacy code bases, a lot of times you have some kind of a networking subsystem which everyone builds, because as the networking stack grows and as the number of requests that you have grows, you have your subsystems, you kind of try to abstract away some of your networking code, or you use some existing networking library, but you write up your own wrappers over that to abstract away your request creation logic, for that matter, right? Or you can even have scattered request creation code in your view controllers when you have special information to attach in your requests. Also, you might have helpers or singletons, because if there is a lot of code duplication for some kind of attachments, you might have these singletons who are lingering all over the place and attaching or running this duplicate code for you again and again, right? So let's look at the current thing that's out there. So this is Artsy. This is Artsy's app. It's a beautiful app. And they recently open sourced their iOS app, and I was looking inside to see, how do these guys do it? How do they do networking? And what they do is this, right? This is an Objective-C code base with a little bit of Swift inside it, and this is like this looked familiar to me because I have seen this before in other apps as well. So there is one file where you have a huge list of constants, and you have your API URLs, you have your base URL somewhere up there. And when it actually came to using these, there was a class like this in which it was returning functions, taking success block everywhere, and it was pretty complex code. Like, if I had to reason about what networking requests this app makes, it'll be pretty difficult for me. I will have to actually read and understand where the code path is, right? So in a similar way, what is the current state of the art, right? The current state of the art is Moya, and coincidentally, this is also being built by an engineer at Artsy. And what this is this. So what they have is a Swift. This is a Swift library, and it can only be used by Swift callers. And what it does is it abstracts away all your network request creation code into an enum. And this enum has computed properties inside. Like, for example, if I look at one request here, so if I look at the create user request, I can see that it takes 2 arguments, and the URL path is /users, okay, and the base URL is given above there, right? So this is /users, and okay, it's a post request, all right, and then in the parameters enum, I can see what parameters it takes, and I can also see what kind of parameter encoding this does. but so this is good, and this is way better than what we did, what we just saw previously, right? But the issue with this is still, if I have to reason about a request, and if I have like 100 requests, this can get very long. These computed properties, and these are just 4. There are actually 2 more which you have to define to actually get it to work, right? So if I have to reason about a networking request, about how it's working, what parameters it sends, I have to jump enum to enum and see what is actually going on, right? And what we also saw is that the Android team at Flipkart was using something much more elegant, and what they were using was this library called Retrofit, which is built by Square. And what it does is it has a very declarative way of writing your network requests, and we really like this. So if you look at it, for example, it converts your request into a type-safe function, and you have these Java annotations which you can use to actually define what the function will do. So basically this is a post request, and it even goes all the way to actually determine in line that what that argument to that function will actually do to the network request. So basically the user ID that you pass to this function will actually replace the path user ID in the URL, and that is a very beautiful way of writing. So in 2 or 3 lines, I can actually see that what will this network request do, what will it take, and what will it hopefully return, right? So the question was, can we do better? Because see, Android is doing a great job here, but in Swift we don't have annotations, at least not custom ones, right? So either we can try to blatantly just build something using code generation like Retrofit, or use something like Moya. But the problem with Moya is in a lot of code bases that we have these days, we have mixed code bases. We are not starting a new app mostly at this point of time. We have an Objective-C code base that we are slowly writing new modules in Swift. So Moya at that point of time is completely out of question, because Moya can only be used by Swift callers, right? So if we have to do something, what is the basic requirement that we have? Like what is the feature, or basically what are the principles that will guide us to actually build this, right? And there are 3. So we want it to be organized. We want it to be one place for all our requests. So I don't want to scatter my requests all over the app, right? And the second thing is, I want it to be concise. It has to be simple, and for a Swift developer especially, or for an iOS developer for that matter, it has to feel familiar, right? It shouldn't have a learning curve that, I have to do this, I have to do that, and this is how I'll do it, right? So it has to be simple and familiar, and it has to be readable. Like we would try to, our aim should be to get something like Retrofit, because if you look at Retrofit's readability, it's very good, correct? So WebService is the solution that we have built for this, and it's a very simple and declarative way to write network requests. And I understand declarative is a word thrown around a lot these days in open source libraries, but I'll show you what do I really mean by that, right? And it helps you put all your request creation code in one place. And the basic thing that WebService achieves is that your API becomes a type in your app, and your requests become functions. And the best way to really show this to you is to actually give you a demo. So I'll just jump right into the demo. And just to give you a little bit of context on the demo, I am assuming you guys are familiar with this. This is an HTTP bin website, and it's just a random API that people can use to check their networking code. So it has these URLs in which, for example, it has http://bin.org/IP, which just returns your IP back. And you can do get, post, patch, delete, whatever request that you want to do, and it will just behave like a normal server would, right? So we'll just assume that we are building an app that this is our API, right? So we'll just jump right into the demo. So above this is just initialization code. We can just ignore that. So for example, I'm building an API. I simply have to start with a class, and let's just name our API something. For example, let's just name it bin, so that at least I don't have to say HTTP again and again. So let's just name it bin, and we will inherit the protocol, conform to the protocol WebService. And WebService protocol only needs 2 things. First of all, it needs a base URL. So I need a server URL, and that's it. And I need a network interface, and I'll come to this later on. So basically, a network interface is what tells web service how do I actually communicate with the network. And we will just use a Swifty instance, which I'll come to later on. And that's it. This is all the setup that the web service requires. Now you can literally start writing your requests. So for example, let's make a request to this IP URL, IP path, which is just a get request and gives you your IP back, right? So let's make a request called static. So our request is a function, right? So I have to make it a function, and let's name it get IP so that everybody can use it, and it takes no arguments, so our function will also have no arguments. And because these are functions which will give me created requests, I have to return a request here, right? So let's just return a network resource, and a network resource is nothing but a wrapper over the URL request API and Apple. It's just a wrapper which supports some extra functionality. So just not to confuse you, this is just a request, right? And that's it. So now that I see that I have to return something, I have to start by returning something. And the starting point for all web service requests is the variable server, because server URL that you gave above automatically leads to the computation of this URL, this variable called server, on which you can actually proceed. So this server is nothing but your base URL in a network resource form, right? So it's already computed for you, and you start by returning server. And then now that we see that the path is /IP here, right? And it's a get request. So you just say server.get and the path, which is IP. And this is it. This is all you need to create a get request. And just to give you a little more idea about the syntax, let's try to create a post request here. For example, if I have a post request in my app which says create user, and it takes just a name, for example, right? And again, I have to return a network resource. And again, I start with the same starting point, return server. And this time it's a post request. So I just have to say server.post. Sorry. And then the post URL, because this is actually the URL, right? So I say server.post, and that's it. Now I want to attach some JSON data. So now you can see the chaining syntax comes in. So you can keep on chaining more and more functions to actually attach more and more data and keep on modifying this request as you go. So I can just say .json, and it takes a dictionary. So let's just create one. So we have to give it the username, and this transforms to the function argument that we just took. And that's it. You can keep on chaining as much as you want. For example, I want to attach a special header to this. Why not? Not header. And I think you get the idea here. So this is how it works. And if you look at it, this demonstrates the principles that I talked about, right? This is concise in 3 lines or 4 lines. For that matter, I am finishing up my requests, and it is extremely readable. So, for example, this request will create a user. I can understand that this request will create a user. It will take a name as a parameter. It's to the variable post. Sorry, it's to the path post. Okay, and it takes a JSON. It creates a JSON of username and puts that name here, and also sends a header along with it. So it's very easy to reason about what I have just written here. You can easily understand what will be the actual request that will be made, right? And that's basically the web service protocol. So sorry, yeah. So just to reiterate, like I said, your API now becomes a type, right? And your request become functions. And just to show you how the call set looks like. So just in case, now that you have built this, how do you use it, right? And how you use it is basically you say bin, which is our type now, and you say get IP, which is the request that we made, right? And you just say load, and that's it. So this is how easy it is to actually call a web service request. And I'll tell you more about how this actually works, but this is basically the call site of a Swift caller calling your API. So it's very simple. Even at the call site, you get your type, which is basically the API that you're calling. You create the function, and you call that function, and you just call load on it. You can load data, you can load JSON, you can load list, whatever it is that is your function, right? So so this is basically how it looks. But the best part is that this also works from Objective-C, unlike Moya. And in Objective-C, the syntax is almost as good as the Swift syntax, which is basically you call the same function on the bin type, and you say .load, and that's it. That's literally it, right? So Yeah, and one of the best features about building it this way using the chaining syntax is that you can keep on changing the types of the request internally, right? So, for example, if you look at that function that we wrote about the get IP request, right? And I just say return server.get IP. Now, if you try to do .json, now web service understands that you cannot attach a JSON body or any body for that matter into a GET request, because a GET request does not carry a payload. So the best part is you don't have to wait till the runtime to actually get this error. This is a compile time check in web service, and you will find out that this is not possible, right? So the moment you fix it, that works. So it is much harder to build up wrong requests into the web service, right? And so you saw the chaining modifier syntax in which I do .get, .post, or .header. So there are a lot of these options available. So you have all the HTTP methods, of course, and we will be adding more. And you have stuff like you want to attach queries, you want to attach form encoded data in fields, you want to attach JSON, or you literally want to attach NS data directly. That's also fine, absolutely, right? You can attach headers, or you can even do multiple headers at the same time, or you can change the content type of the request if you want. And there are some special ones which I will talk about, which is basically you can set priorities on requests. You can set deliver on, which I really like because it's something that even we use a lot. And you can even tag requests for that matter, right? And there is something that I would like to talk about. So I would like to talk about the deliver on one. And what the deliver on basically does is that, for example, you have this network request in your view controller. Although you shouldn't put it as just an example, right? So you have this network request, you call this network request on the view controller. So whatever the result you get, you will probably want to update your view. So you might want the result of the network request on the main thread, which is basically what a lot of network libraries automatically do. They will return your request onto the main thread to you, right? But what if you have some kind of a flux pattern or any architectural pattern that you're following, and in the background you want to receive your response? You don't want to go to the main thread, switch it back to the background thread, do your DB operations or caching operations for that matter, and then get back your data onto the main thread, right? So what if I want to actually get it on a background queue and don't avoid that context switch altogether? So you can absolutely do that here. You can create your own background queue. I have just created one, for example, here. And when you are actually calling the request, you can actually say deliver on, and it will deliver it to you on that thread instead of its predefined main thread for that matter, right? And you can just call load on it and just go on with it, right? And another thing that I want to talk about is priority, right? So if you have, for example, requests that are in the background or which are not user interactive or called by the user, and you want to complete this request in the background, and you might be on a slow connection like 3G or 2G for that matter, even 4G is not that great anyway. So you can actually set either on the call side or in the web service itself that you can say that this priority is high, for example, right? Or this priority is low. And this translates that priority all the way to URL session to tell it that, this priority is this much, please try to load my other requests faster or other requests slower, right? So this syntax carries over all the pace. You can do these chaining operations in the web service itself, or you can do them in the call side. So those are the basic ones, right? And it's because of this, this is built in Swift, although it's completely usable from Objective-C. It's extremely easy to extend the web service. And what I mean with that is that, for example, I have these methods called .fields or .data or .query to attach query parameter, but I want my own method which basically, for example, attaches encrypted data. So I can just write an extension on the network resource, because that's what we operate on every time we use this chaining syntax. And I can just say encrypt, and it always has to return a network resource, because of course I want to keep on continue to provide the chaining syntax that we have, right? So it doesn't return a network resource, and I just say let encrypted data is equal to some kind of encryption that I perform, and I use the existing method called self.data, which is already there to attach a data, right? So you create your own custom data, you put it there and return self, and that's it. You just added a new chaining modifier to the web service protocol, and there it is, right? So this is the way web service actually abstracts away all that actual networking code from the call side and just lets you keep your request creation code in one place. And it gives you a very simple syntax to load these requests, which is just .load. And there are multiple kinds of these load methods you can use, for example, loading JSON or loading raw data and stuff like that. And having multiple web services in your app is absolutely all right, because you can have a web service for accessing your API, and then you can have another web service which accesses your CDN, which just downloads images, for example, so you can have priority low in all the requests there. I'm just telling you a sample use case here, right? So, here the abstraction is not really equal to opacity, because you still have very, very granular control over how the actual networking takes place, and that actually comes to you with Swifty. And web service is just a model inside Swifty, but Swifty is the actual networking stack that is powering all this networking code, right? So Swifty is obviously based on URL session, and it works using GCD APIs like dispatch group and serial dispatch matrices, right? And the only thing that you need to know is that its initializer takes an URL session configuration, and that is also defaulted if you don't really want to provide one, right? And it has a deep integration with URL session task matrix API, which I'll show you why it actually matters, right? So one thing that I talked about earlier was in our complex networking requirements, sometimes you want to attach an OAuth token or some kind of a token that your API requires to authenticate or rate limit your requests, right? And one of the ways that you can do this, is use a constraint. So is this working? Yeah. So one of the ways you can use this, do this is using a constraint. And what a constraint really means is that these are classes which determine that a network request should fire or not fire, or does it need some more stuff to actually succeed if you know it beforehand. And if not, these classes can asynchronously satisfy those constraints before actually letting your network requests go through over the network. And a very classic example obviously is OAuth token constraints, right? Because if you want to present a UI, let the user log in and get an OAuth token from Facebook or Twitter for that matter, and then call their APIs, instead of writing all that code in your call site where you actually do it and duplicating that code at 2-3 places, you can actually use a constraint to achieve that. And another use case of constraints is, for example, if you want location access before firing a request, for example, if it sends GPS coordinates, you want to make sure that you have location access. So otherwise, if you look at this, if you don't have such a construct, you will end up making it your own, and you might end up with that callback hell in your view or controller code, which is not so pretty that way, right? So you can, and they provide asynchronous APIs, so there is absolutely no hurry that you have to do, and there is no hurry to, and there are no block threads for that matter. There is no thread waiting on your request. There are threads which just go through, service other requests which are not constrained, right? And it's a very simple syntax. We take the principles of web service here and we carry it over here. So you just have two functions, and which are pretty much self-explanatory. We have one function which says, is constraint satisfied? And it gives you a resource. So every request that goes through Swifty, it will ask your constraint, are you satisfied? Are you okay for me to send this request over the network? And if it says yes, all is good, and then the request just goes through. If it says no, then what Swifty internally does is it attaches your request to this constraint, it makes it wait, and it asynchronously calls the satisfy constraint function for that resource. And what it really does is that it gives you an asynchronous time to actually do whatever it is you want. You can present UI here, you can present location permissions or any permission for that matter. You can actually perform another network request to get an OAuth token and do whatever it is that you have to do, and just call finish. And the moment you call finish, Swifty decouples that request internally from your constraint and just lets it go through, obviously provided all the other constraints are also satisfied, right? And the same way comes in interceptors. And interceptors is also very powerful logic, because in the sense that a lot of times you want to do something before every request, or you want to do something after every request. And a good example of this is, for example, you have some headers that you want to attach to every request, or you have some session information that you want to extract out of every response, right? And interceptors are a great place to keep that logic around. And there are two kinds. One kind is basically the request interceptor, which are run just before each of your request fires over the network. And the second one is a response interceptor, which is just run right after that your request completes, but right before the response actually returns to the caller. So you actually have that window to modify the request, modify the response, for the, right? And before it actually returns to the caller. So request interceptors are, like I said, it's a great time to attach authentication or important headers into your request, or things that you might think that the request will need to succeed. But you can do it fast. If it's a long-running task if it's a long-running task that you need to perform before a request, then you would rather use a constraint, because these are synchronous in nature. Although they are called in the background thread, they are synchronous, and the request is actually waiting on these to finish to actually go through into the network, right? And the syntax is still very, very simple. Just one method, which is intercept resource and then give back the resource, which is basically it will give you the resource, attach whatever it is that you want to do. That chaining modifier syntax works here as well. So dot header, dot JSON, dot query, everything is valid here, right? So you attach whatever is on to do, you modify the request before it just goes through, and you just return that resource, and Swifty will just carry it through the network or the next interceptor for that matter, right? And same way in the response interceptors, it's a great time to extract information out of your resources, which you want to do out of every response. And other use cases can be, for example, you want to collect statistics, or you want to see the response failure rates, that or you want to log, what is going on and how much time are the requests taking. So this is a great place to actually compute that property, right? So and again, the exact same syntax, which is very simple. That and the best part about response interceptors and the force failing syntax is that you can actually force fail or force succeed your request. So for example, for some ungodly reason, my server, when it returns a 204, I want to fail my request. So this is all the code that I need to write for it. I just have to check the status code of the response, and if it's 204, I force fail it. So instead of calling the success block, which it was eventually going to call up the caller, it will now go to the failure block because I have failed the request here. So regardless of what the server sent, I actually modified the request response in flight and sent it back to the caller, right? And the best of both worlds is basically the constraint, what I call the constraint and request interceptor combo, in which, for example, it fits very well into the OAuth logic, in which you have one single class and you don't have to save that OAuth token when you get it from somewhere, right? So in that class, you can have a simple property called the OAuth token. You can, Swifty will satisfy you once the app starts, so you get that OAuth token once, and then post that, this constraint class will also act as a request interceptor. So every time a request comes through, it will keep on attaching that OAuth token that you just received from the first time, and all your requests will basically succeed that way, right? So this is what basically the request lifecycle in Swifty looks like. So the caller calls it, the web service creates the actual request, you call .load on it, and it goes all the way to condition managers or constraints for that matter. And when all the constraints, so the constraints are satisfied in parallel. So if you have multiple constraints, they will be satisfied in parallel asynchronously. And when they're all done, all the request interceptors are then, the request is then passed through all the request interceptors, and then it actually is handed over to NSU for the actual networking. And when the response comes back, we again run the response all the way through the request interceptors serially, and then we return it back to the caller, right? And very important question, why Swifty, right? So if you look at Alamofire and AF networking, its sibling, is pretty much the industry standard in iOS for networking. And why would you use Swifty? So it depends on your use case pretty much, because Alamofire is very, very good if you want quick access, because if you look at its syntax, you use their singleton, you say alamofire.request, and that's it. If you're hacking up a new app, Alamofire is great because it will give you very, very quick access to network without all the little details, without caring about the little details of an URL session. But Swifty is something that I believe that you make your own. You customize it with your business logic, you add up your constraints, you add up your chain of interceptors, and you use it to service your needs that were all over the place, that might have been all over the place in your networking code, right? So, and multiple instances of Swifty, just like web service, are absolutely alright, because you might have different servers that you might communicate with, for example, an analytics server or a tracking server and then your main server, and different Swifty configurations might be required for it. So it's absolutely alright. Otherwise, in Alamofire, you will actually have to go the way of subclassing Alamofire session manager and then maintaining multiple sessions across your app, right? So in the case of performance, the good part is Swifty actually outperforms Alamofire in most of the requests, and although the cold startup time for Swifty is slightly higher than Alamofire, post that, for example, in a GET request here, Swifty it's not a very huge speed bump, but the point that I'm trying to make here is that because of all the functionality of constraint interceptors, you do not lose out on performance if you think that, so many features I can't, it will probably be a performance hit for me. So it's not a performance hit, it actually improves slightly a little bit. In a post request, it's kind of similar, where it's sometimes this is faster, sometimes this is faster, and you don't have to believe me, there are performance tests in the example project for you to check out, right? And there are some limitations as well, which we are working on, in the sense that there is still no request retries that you can do, but we are actually planning something for this. and there is no HTTP digest authentication till now, and this is also in the works. And of course, you cannot do SSL certificate pinning right now with web service yet, right? And the good part is most of those points actually translate into the roadmap for us as well, in which we will have a .retry modifier in which you can just say .retry 2 times or 3 times, and then you can specify in how much time you want to retry again and again to avoid exponential backoff, and it will just work. So we will keep on adding features to Swifty and web service with just this modifier syntax, which makes it very, very easy at the call side as well as writing your request in the web service as well, right? And obviously, again, for authentication, we will keep on adding more syntax, more modifiers just to make it super easy. And this mock function is something that we really like and we really enjoy. And I'll just let you share it with you for a second. So what mock does, as the name says, is that, for example, if I'm working on a new feature for which the API is not ready, or a very common use case is tests, for example, right? So if the API is not ready and your server team has given you a mock response, so you can just use .mock modifier on a request, and you can say which local host API that you want to hit, or even better, you can even say that which file is it that you have stored your response in, and you will get that response directly. So you don't have to worry about setting up your own local server, for that matter, or manually putting in read from file and NSURL file manager and everything. So you can just say .mock and it will just work. And the roadmap is again the same thing: retry, authentication, mocking, and we want to expose more of the URL session outside. So even though you're using Swifty for networking, you can use more of it. You can customize more of it into the URL session thing. And obviously, yesterday night, like this Swift 4 came out, so we'll be adding a Swift 4 release branch as well. So you can check that out as well. And the best part is, this is not in the roadmap, by the way. This is already there, and this is something that your QA engineers will love, and even you might use it time to time. And this is the Swifty Inspector, which basically, like I said, it deeply integrates with the URL session task metrics API. And what it does is, it gives you a detailed view of every request that is going into Swifty and what is coming out, what is the status code, what headers went through, what body went through, and what was the response. So this is a great way to actually debug in development, right? And that's pretty much it. So it's open source right now, and please check it out, and we'll love your suggestions and feedback. Thanks.
Is it audible on the speakers?
Yeah.
Nice effort. I'm myself an adult developer, and one of the reasons why I attended this talk is because I was interested in seeing if there's something we can take from the effort that you've done. Okay. You compare it to retrofit, obviously. We've been using that for many years, and that is definitely the gold standard. Yeah. One of the things that you mentioned was you don't right now support SSL pinning.
Yes.
The certificate pinning.
Yes.
Would that be a function of the HTTP library and not the layer here? I'm assuming that the Swifty library falls back to something else for doing HTTP itself.
Yes.
That you don't actually run the HTTP request yourself.
Yes.
So wouldn't certificate pinning fall under that and not really on the domain of Swifty?
Right. So I understand what you're asking, and so my slides can be a little confusing in the sense that I talk about all the syntax of how to write a request in the web service, but then I talk about Swifty, right? But web service is just a module inside Swifty. It's basically just a protocol to how to write your requests, right? The actual networking itself is handled by Swifty, and Swifty is the driver that drives these constraints and interceptors together all the way to the networking stack. And the actual networking does happen via NSURL session, what you're saying, right? Because yeah, sorry, you're trying to say. Yeah, so what we are trying to do is that Swifty right now does not expose the full NSURL session methods, and one of those methods is SSL pinning, right? Okay. So the only thing that we have to do is expose it to the caller, because right now Swifty internally handles all the URL session quirks and just gives you the response somehow back, right? So we just have to expose more. That's all. Expose more of the NSURL session APIs.
The NSURL session, I'm assuming, is the HTTP client part of the iOS.
Yes, that's the core. So that is the last thing that you use for networking.
That everything on iOS uses.
Absolutely. So even if you use Almofire or Siesta or all the all the networking libraries out there internally use NSURL session.
I have a couple of questions.
Yeah.
So you were talking about this mock extension function.
Yes.
Right? So say for example, if I'm about to ship a code, right? So the code that I ship for production is the same code that I use for testing, right?
Okay.
So when you do a .mock, how do you ensure that like it's the same code that you're going to ship, right? So you can't really have mock in the interface that you define. So how does it work? Like, do you have two different classes with?
So is your question around that? What if I ship mock to production?
Correct.
Okay.
There
so
should be a way where I should not be able to ship, right? Because you're defining your entire network request.
Yeah, yeah.
So that is the thing that you're going to ship.
Yes.
So if
yes.
mocking happens somewhere, say for example, you pass in a different NSURL object.
Yes.
That can mock for you or return mock responses for you. That would be a lot more flexible, right? But I don't really understand how do you separate your production code from the code that you're mocking.
So see, the good part about these modifiers that I talked about is that this mock function doesn't necessarily have to be in your web service where you write all your requests. You can use it at the call site itself, like I showed you deliver on, right? So in the call site, in your tests, for example, you can just directly say .mock there and not do mock in the web service itself.
Okay.
So that way you save yourself of accidentally shipping it out. But also we do have internal checklists, and I believe you guys might also have some checklists that you follow before shipping apps in which we check for the mock identifier that is not somewhere in a web service by mistake.
Is it like a lint rule that you have?
Not exactly, the linting is not automated, but yeah, we have a checklist that we check through. But of course, I understand your concern, and we even thought, we might as well put in a compile time check in which that, in the release configuration, it can auto disable mock or give out a warning saying that you are using mock in the release configuration. Is this intended? Okay. I completely understand your concern.
And what about caching, cache control headers? Do you allow?
Yeah, so when we were building Swifty and we talked about all these complex requirements, networking requirements, what we have realized is that a lot of apps have kind of moved away, at least the ones that I have seen and worked with, is that they have moved away from simple response caching, and they abstract the caching to a higher level in the sense that they might want to store core data models or already parsed models. So we kind of refrained from implementing any kind of caching. You can obviously pass in NSURL caching, which is the system caching that you can use, and you can leverage that already because we give you the option to modify the NSURL session configuration. But other than that, we have not focused a lot of efforts into caching because we believe that right now when people build apps, they think about the overhead of reparsing again and again from the response. So they kind of do caching on an upper layer instead of the networking level. That's why we have not done a lot of caching here. Yeah, not yet. But yeah, that is one of the things that, see, the moment I expose more of the URL session, right, you get that method as well, because that is one of the methods that URL session provides. Yeah.
The interceptors which you were talking about, in Almofire we already have request and response adapters which do exactly the same.
Yes.
So, like, still, why should I go for this implementation?
So I agree. See, I have seen the Almofire implementation of request adapters, and it's a great implementation. But the thing with request adapters is that here we couple the interceptors with a constraint, right? And I have seen the constraint logic. Like, for example, if you look at the Almofire README, they have a, for example, of how you could implement the OAuth thing system that I talked about here in Almofire. And if you look at that syntax, it's pretty complex in the sense that they're acquiring locks in your code. So you have to acquire locks so that multiple requests do not come in at the same time here, and you end up getting the OAuth token twice or stuff like that, right? So they have a very complex syntax there. The interceptor part, I completely agree, right? Because interceptors, in their interceptors also, it is pretty much the same logic. But here we give you a simpler syntax, and we couple it with constraints. So basically, constraints is what makes all the difference of shipping up that combo of an interceptor and a constraint, and doing your OAuth thing in one class instead of multiple places. So I am not sure if it's a satisfactory answer, but I understand that request adapters are pretty similar, but constraints is what makes a lot of difference to that logic. So I just understand this part of the question. What happens when a constraint fails, right?
Like when a constraint fails on the callback block, right, that gets called, like that makes you to force to fulfill that constraint.
Yes, yes. Okay.
So
Okay.
Will that get called just once, or will it get called every?
It'll just get called once because it's logged internally. So if it has multiple requests waiting on you, they will all just wait for the same execution cycle. They will not, just force the constraint to execute 4 or 5 times at the same time. And you can even finish a constraint, which I actually forgot to cover in the slides. That finish function that you had, you can pass in an error. And if you pass in that error, all the requests that were waiting on your constraint will fail with the exact same error. So that error gets bubbled up all the way.
So, hello. So, is there a way to group or batch together requests?
Sorry?
Is there a way to group or batch together requests? Like most of the times, you'd be firing out 4 to 5 requests or a number of requests, and then you'd probably be doing something after you retrieve all of those. So, is there something that you thought about?
So it's a great feature to have, like something like debouncing or batching together requests. We currently do not have it, but you're absolutely welcome to contribute that feature into it. And not something that is a focus for us right now, but we'll definitely look into it. It's a great feature to have. I can understand if you're using web service for analytics or events that are not very important or time critical, you can batch them and send them up later on. Yes, definitely. Thank you.